Hello, welcome to a video. I'm going to explain how we can use the slope of a function and its derivative to talk about maximum and minimum points and the growth of the function. So let's go ahead and do this. So first of all, consider the following function. It's a very simplistic one. I'm just trying to keep things simple. Here it is. It's plotted. Now, what's happening to this function? Just look at it. Clearly, it's always positive before point A. It's always a positive slope. Between point A and B, the slope is negative. And after point B, the slope is always positive again. Now, this is kind of intuitive if you look at the graph. But how does this relate to the derivative? Well, at points A and B, the slope is going to be 0. That's the very first thing to realize. That's point A. I just zoomed in, and you can see how the slope is 0. And here's point B. So if we're thinking a bit about this in terms of f prime of x, and I can calculate f prime of x, because we've done this before a few times, I can realize, well, what's going to happen at points A and point B? Well, the slope is going to be 0. We can see it here. But that means also that the derivative is going to be 0. So if I calculate when does the derivative give me 0, I can calculate the x coordinate of A and B. This is really important. I just substitute 0 equals 3x squared minus 6x, and I clear out the equation, and I realize, well, that's going to happen when x equals 0 and x equals 2. So those are going to be the points that are going to have the slope change. So before A, f prime of x is going to be bigger than 0. At A, the derivative is going to give me 0. Between A and B, the derivative is going to be smaller than 0. And at B, the derivative is going to be equal to 0. And after B, the derivative is going to be bigger than 0, just like the slope. Now, we can actually talk about the growth of the function. This is how you do it. Here's my function again. I know the derivative already. And here is the function drawn. Again, the slope is positive before point A, negative between points A and B, and positive after point B. So here is an x-axis. Now, you might be asked to draw this. What's going to happen here? Well, before A, the derivative is positive. As we talked before, I can see because the slope is positive. At A, the derivative is 0. Between A and B, the derivative is smaller than 0 because I'm going down the hill. And at B, again, it's 0. And after B, it's bigger than 0. So, for example, if I substitute within the f prime, in the derivative minus 2, which is here, I'm going to get a big positive number, like at 24. The slope is positive and really steep. So our conclusion is that f of x increases in the intervals from minus infinity to 0. Just minus infinity means minus a very big number, minus like 5 million, doesn't matter, to 0. And this means and, remember, from probability, to plus infinity, to a very big positive number. And it decreases in the interval 0, 2. This is how we talk about the growth of a function. Here's another way to look at it. Now, again, I have the function, and I've realized that this is what was going on. Between minus infinity and 0, it was growing, then it was becoming smaller, and then it was growing again. We say that f of x increases, then decreases, and then increases again. Now, it is clear that when the derivative is 0, we know that it's points x equals 0 and x equals 2. Those are the points where the slope is 0, or, which is the same thing, the derivative is 0. Now, by looking at this, I can realize, well, when x equals 0, it must be a maximum. Just look at the arrows. Clearly, it can't be a minimum. And when x equals 2, it's going to be a minimum. Just look at the arrows. Of course, it's going to be a minimum point. Now, those might be, will be in general, the only two instances of derivatives giving you 0 that you're going to see. There is another one in which the function just happens to flatten out and then goes up again. Now, that's not going to be very common, but just keep that in mind. Here in this graph, I can see it clearly. Here I'm going to have a maximum, and here I'm going to have a minimum. So that's the way in which we can figure out whether a point is a maximum or a minimum. We just calculate the derivative, equal it to 0, find the values of x, and then I just study the growth. And by studying the growth, I can tell, hey, where it's going to be a maximum, where it's going to be a minimum. But there is another way to figure this one out. And we're going to look at it right now. We have to use something called the second derivative. So We calculate the derivative, here it is, and we know that the slope is 0 by solving this equation. Again, x equals 0 and x equals 2. And we know that there probably is a maximum or minimum there, but we don't know for sure which one. So we can study the growth, or we can use the second derivative. The second derivative is simply the derivative of the first derivative. So it's going to be 6x minus 6. Now I substitute the values 0 and 2 in the second derivative. And this is what I'm going to get. For the second derivative substituting with x equals 0, I get minus 6. For the second derivative substituting with x equals 2, I get 6. If I get a negative number, it means that I have a maximum. If I get a positive number, it means that I have a minimum point. So that's how I can use the second derivative to figure out whether points are maximum or minimum. It's a very interesting method, very useful in many occasions. So here's an exam exercise, more or less an example of what you could be asked to do. Here's a function. They asked me to calculate the derivative and determine the maximum and minimum points of f of x. So I calculate the derivative, here it is, and I just have to equal it to 0 to find out where the slope is 0. Now to solve this equation, I simply use my quadratic formula. So I end up with that plus 4 minus 6, which is going to be 2, and 8 minus 4 divided by 6 is going to be 2/3. Now I know that the slope is going to be 0 when x equals 2 and x equals 2/3. To know whether they are maximum or minimum points, I use the second derivative. Here is the second derivative, 6x minus 8. For x equals 2/3, I'm going to have, that is going to give me minus 4. So I'm going to have a maximum when x equals 2/3. When x equals 2, I'm going to get that the second derivative gives me 4. So I'm going to have a positive value and a minimum when x equals 2. So I can calculate the exact coordinates of the maximum point by saying, well, it's 2/3 and f of 2/3. I substitute in the original equation up here, and I get this not very nice number, but again, also a possible result, and a minimum point at 2, 1. Much nicer, isn't it? Well, that's how you calculate maximum and minimum points. You can do it looking at the growth, or you can do it looking at the second derivative. Thank you very much for watching. See you next time. Goodbye.